Hello everyone, welcome back. In this video, we'll be discussing about the second and the third problem of yesterday's weekly contest. Find longest special substring that occurs thrice, 2 and 1. Both the problems are exactly similar, only difference lies in the fact that the first problem has slightly lesser constraint whereas the second problem has slightly greater constraints. So in this video, we'll be discussing two different approaches to solve the problem. First, wherein we start from the brute force solution and then optimize it step by step to fit in the given time constraint. The second solution lies on the fact that the given string is given kind of string in the problem is having some special property, that is it is made up of a single character. So we will make some observation based on which the problem becomes straightforward. So if you want to understand one of the approaches, all the timestamps are there in the description down below. Feel free to move back and forth in the video. With that, let's get started. The problem states that you are given a string S consisting of lowercase English letters. A string is called special if it is made of only one character. For example, the string ABC is not special because it is made up of three distinct characters A, B and C, whereas the string DDD, ZZ and F are special because they are made up of one character. This entire string has just D, this entire string has Z and this one has only F. Now we need to return the length of longest special substring of S that occurs at least thrice. If it is not possible, if there is no special substring that occurs at least thrice, we have to return -1. So let's take an example. Let's say the given string is AAAA. Here the substring AA occurs thrice. You can see this is one, this is also AA and this is also AA. And AA is also a special substring or a special string because it just consists of one character, which is A. So AA is a valid candidate and the length of this is 2. So you can try out any other possible combination. You will not be able to get a special substring which occurs at least thrice of length greater than 2 here, and hence the answer here is 2. So hope the problem statement is clear. Now how to solve this? As always, I would encourage you to pause and try to think of the brute force solution by yourself before moving forward. So the brute force solution is straightforward. You can just simulate whatever is given in the problem statement. So you want to find out the length of the longest special substring of S. So you will try out the longest substring possible, that is of length n. So you'll say, is a substring of length n possible or not? In other words, is there a substring of length n which occur at least thrice and which is special as well? If there is a substring, if there is such a substring of length n, then the answer is n. If such substring doesn't exist, then you will say answer is not n. I will try out next best possible answer, which is n-1. That is, you will say, is there a substring of length n-1 which occurs thrice and it is special as well? If it is possible to get one such substring of length n-1, the answer is n-1. Otherwise you will try out n-2 and so on and so forth, right? Now let's just take an example. Let's say we are trying out substring of length 3 for this particular example. So let's say you already tried out substring of length 10, 9, 8, 7 all the way and you didn't get any of these as a valid answer. So you are now trying out substring of length 3. So how will you figure out whether there is a substring or whether there is a special substring which occurs at least thrice of length 3 or not? So for that, what you can do, you are first of all you are interested in substrings of length 3 only. So one of the approaches could be, let's just figure out or isolate all the substring of length 3, right? And once you have all the substrings of length 3, you can then understand or then can basically filter out which one occurs at least thrice, because you're only interested in those substrings which occurs at least thrice. And if you figure out such substrings, you will see which of them is special. If there is at least one special substring out of those, you have the answer. So let's just try to dry run this with length of 3. So you will first enumerate all substrings of length 3: AAC, ACA, CAC, and so on and so forth. So if you will just enumerate everything and put a frequency over it, you will see AAC occurs once, ACA occurs twice, CAC occurs once, and so on and so forth. So we will first filter out which of them occurs at least thrice. The answer is none of them. Like none of them has frequency greater than equals to 3. So clearly there is no substring which occurs at least thrice of length 3. So there is no point of checking whether there is a special substring or not. So 3 is not possible. We will try with 2. So again, let's just do this one more time. We will try to take all the substring of length 2: AA, AC, CA, AC, CA, and so on and so forth. So if you do this exercise for all the substring of length 2, you will get something like this. You will see AA occurs once, AC occurs thrice. This is AC, this is AC, and this is AC as well. So AC occurs thrice, CA occurs twice, AB, BD, and DA occurs once. Now here you will first filter the substring which occurs at least thrice. So all of these will go away and only valid candidate you have is AC. Now you also want your substring to be special as well, that is it should contain exactly one character, but it is formed of more than one character, A and C. So hence this is again not a valid candidate. So you are not getting any valid candidate with length 2 as well. So 2 is also not the answer. You will try substrings of length 1 and again do the same exercise. So hope the entire approach is clear. Now what will be the pseudocode? The pseudocode will be very straightforward. It will look something like this. We will try out every possible length. You can optimize this slightly by saying that you are sure that there will not be any substring of length n and n minus 1, because you want a substring to occurs at least thrice. So length there is only one substring of length n and there is only two substrings of length n minus 1. So none of these candidates will be a valid candidate anyways. So you can just skip iterating over substrings of length n and n minus 1 and start from n minus 2. So you start from n minus 1, n minus 2, go all the way to 1. Now for each of these length, you first need to build this frequency map which we have built before. So if you remember, we built something like this for each of the substring, how many times it occurs. So we can do the same for each substring of length result. We can simply build a map how many times that particular substring occurs. Now once we have this map, we can simply iterate over it and then filter out based on our criteria. The first criteria is the substring should be special, that is all the characters should be same. And second criteria is the count of such substring should be greater than equals to 3. If these two are satisfied, we know that there is a special substring which occurs at least thrice, and hence result is a valid size of that special substring. So we'll simply return result because we wanted the maximum size of the substring. Otherwise, if it is not possible for any of the substring of length result, we will try out result minus 1, result minus 2, all the way up to 1. If substring of length 1 is also not possible, we will simply return minus 1, right? So what is the time complexity of this entire solution? The time complexity is basically we are iterating over a loop here which will take order and time. Inside this loop we are again running a loop which will go over all the substrings, or left and right endpoints of all the substring, which will again take order and time in worst case. And finally inside this loop as well we are finding out a substring of length, we are finding out a substring of s in the range L to R. So this will also take order and time in itself in worst case. So overall the complexity is order n cube for the first part of the algorithm, and for the second part we are iterating over all such substrings. So this is like this iteration is order n, so there is n such substring, right? And we are then finding out whether characters of each, whether there is how many unique characters are there inside the substring. So that will also take order and time in worst case, and this is just order 1. So basically we are doing n square plus n square operation inside a order n loop. So overall the complexity is order n cube, which is fine for the first problem where n is only up to 50. So if you were not able to come up with the brute force solution, this is the very right time to pause the video and try to code and get the second problem accepted, because the constraint here will allow order n cube solution to pass. But this n cube solution will not pass for the third problem, which where n is 5 into 10 raised power 5. So we need to optimize this. So which of the factors you can optimize? We are iterating over, so there are 3 n's, right? First n is coming from the fact that we are iterating over all the substrings, so that's fine. Second, we are iterating over all the substrings of a particular length, so that also you need to do, right? Third, we are trying to find out a particular substring in the range L to R completely, just to figure out their count or frequency. So which of these 3 n you can avoid easily? So the answer is the third n you can avoid easily. Basically you don't care about the actual string here. So AAC, ACA, you don't care about them, you just care about how many times they occur. You do care about that all the characters in the substring should be same, but this is something we can do in other ways as well. So let's just forget about this condition for time being. Let's assume that you just need to figure out a substring, or you just to figure out whether there is a substring which occurs more than thrice or not. So for that you don't need actual substring, instead you just need the frequency and a way to distinguish that AAC is not equals to ACA. So the simple way to do this is just hash this entire thing. Instead of maintaining a string, maintain an integer, convert the string to an integer and maintain the integer and the count respectively. So hashing we discussed in yesterday's video as well, where we were discussing the fourth problem. If you don't know about it, I would strongly encourage you to go through that particular section of the video. I will link that somewhere in the description and the top right eye section. You can check that out. Just to give you a brief background, so hashing is a way to convert the any given string to a single integer, such that if you convert, let's say, a given string to a number x and you convert another string to a number y, the probability of x being equals to y is very small unless the given string, underlying string which you have converted, are equal. So if this is, let's say, ABA and this is BAC or BAB, the probability that x is equals to y is very small. A good hash function ensures that, and if they are indeed equal, then the actual string is also equal, right? So that's what a hash function actually ensures. So a hash function is just a mathematical function, so you can write any sort of function there, right? You can say, okay, hash function of a string is simply the summation of characters. So this is one such example. Let's say you say, I represent a by 1, b by 2, c by 3, and so on and so forth. So hash function of hash of BAB can simply be 2 plus 1 plus 2, which is 5. Similarly, hash of ABB is 1 plus 2 plus 2, which is again 5. So notice these two hash values are equal, but the underlying strings are not equal. So this is a bad hash function because the underlying strings are not equal, but their hash values are equal, right? So this is what we need to avoid by making our hash function a bit stronger. So instead of doing this simple mathematical formula for this hash function, you can simply say, okay, I will also take care of position. So if I have to now find the hash of BAB, I will say B occurs, let's say, at position 1, A occurs at position 2, B occurs at position 3. So the hash value would be 1 cross 2, which is 2, plus 2 cross 1, which is 2, plus 3 cross 2, which is 6. So the hash value would be 10. Similarly, the hash value of ABB this time would be 1, 2, 3. So 1 cross 1, 1, 2 cross 2, 4, and 3 cross 2, 6. This time it is 11. So notice these two hash values are different. So by just simply changing or adding the position to your hash function, you are managed to avoid some collisions here. But this is also a weak hash function because it is easy to have collisions in this scenario as well. You can think about it. So we came up with this particular hash function wherein we are saying we will consider both character and position, but we, instead of directly multiplying with position, I will multiply with some prime to the power position, right? So this is what we used as a hash function in the last problem or the fourth problem, and we will use the same in here as well. So in simple terms, we just converted each of these values to their, like this is at position 2, so 2p square, position 3, 2p cube, position 8, so position 9, so 2p9, and so on and so forth. So if you have to find out the value of this, you will simply sum all of these and you will get the value, right? So figuring out a hash function of a string is now easy. And again, if you need to find out the hash value of this, you can simply sum up these things. Only thing which differs is this time you have to divide by p cube as well, because if you take A independently, A will be at position 1, B will be at position 2, and this A will be at position 3. But in this case, this A was at position 4, 5, and 6. So you do p power 4, p power 5, p power 6. But in this case, you will do p power 1, p power 2, and p power 3. So that's why you have to divide it by p cube so that everything else will be on the same scale. So that's just a small thing. You can refer to the other video as I mentioned for greater details. So we know how to convert a string to a hash value. So what we can simply do in our algorithm, we can get the hash value of this string in just order one time. Now once you get the hash value of the string in order one time, this entire order n will be completed order 1, and this part of the solution will no longer be order n square, instead it will be order n. Now the second part where we are checking whether all the characters should be same or not was also order n here, because we need to iterate over the exact string. But now we don't have actual string, we have an integer. So we need a different way to understand whether all the characters are same or not. So I would strongly encourage you to pause and try to think how to optimize this part of the solution as well. Basically you need to figure out whether all the characters of the current substring is equal or not. So hope you thought about it. The answer is simple. So you just have 26 characters, right? And you know the length of the substring, which is result. So you, let's say if result is 5, you know this will be one candidate, this will be another candidate, right? And so on and so forth. So you can simply find the hash value of all these 26 possible candidates. Now whenever you consider a hash value here, you will simply check whether this hash value lies in one of these 26 values. If it is equal to one of these 26 values, it means all the characters are equal. So this part, which was previously order n, this is now converted to O of 26, which basically says you will be doing 26 comparisons here to understand whether all the characters are equal or not. If it is equal, you will then further go on and check whether you have more than 3 such substrings or not. So overall this part of the equation is now order n into c. So the complexity now is n into n plus n into c, which in turn is equivalent to order n square c, right? So c here is 26, n is 5 raised 10 power 5. So this is definitely better than the previous one, given c is very less than n, but even this is not sufficient to pass the given time constraint. So before trying to optimize this, let's just quickly look at the pseudocode. The pseudocode is exactly what we discussed. We will convert this map of string comma int to a map of int comma int, right? And as discussed, we already have a function hash which can give us the hash of any range L to R in just order one time. Now once we have the hash, we simply iterate over all the hash and the count. Now because we no longer have the actual string, we lose the capability to understand whether all the characters are equal or not. So for that, what we will do, we'll simply check whether this hash is equals to one of the hash of where all the strings are equal and has the same length result, right? So you will simply check this, and based on that you will decide whether to consider the current string or substring or not. If you can consider, you simply check whether you have enough of them, and if you have at least 3 of them, you will return that as a result, otherwise you will return -1, right? So hope this part is clear, but as discussed, the complexity here is order n square c, which is not sufficient for the given time constraint. Now how to solve this? So okay, there are two things, right? First is this n, right? And second is this n. So which of these two n you can remove? So first n is saying that you are trying out all possible answers. You will try n first, then you will try n minus 1, then you will try n minus 2, and so on and so forth. So if you are doing kind of linear search here, so you will check if binary search is applicable or not. If binary search is applicable, you don't have to try out all the n choices. Instead, you can simply try log n number of choices and still get to the optimal answer. So the answer here is yes, binary search is applicable. So because binary search is applicable, you can simply do a binary search over result, and this entire thing will stay as it is, and instead of this n, you will simply have log n here, right? And everything else will stay as it is. So let's just discuss, let's just see why binary search is applicable here. So if you remember, if you have a sample space and you have to figure out or search a particular thing, you divide this sample space into half. If you are able to determine that I am sure that I have to go left and I can skip the entire right half, or you are sure that I have to go right and skip the entire left half, then binary search is applicable. So in this criteria, in this problem, we are trying to find whether or what is the optimal size of the substring. So let's say you are trying out a substring of size x, right? And you, after doing this operation, you understand that okay, there is actually a substring of size x which is special and is occurring more than 3 times. So if result of, if you have a substring of size, such a substring of size x, does it make sense to search in the left half at all? Note that if there is substring of size x, there will surely be a substring of size x minus 1 as well. There will surely be a substring of size x minus 2 as well, and so on and so forth. So if x is true, x minus 1, x minus 2, x minus 3, all of them will be true. So it doesn't make sense to search in the left half at all. You can simply skip the left half and only search in the right half, because you want the largest possible substring. So you'll only search in the right half. If that's not the case, that is, you don't have a substring of size x which is either not special or doesn't exist more than 3 times in the original string. So in that case, if substring of size x is not there, substring of size x plus 1, x plus 2, all the way up to n will not be there. Why? Because uh, if you're not able to find a substring of size 2, how will you be able to find a substring of size 3, right? Because if substring of size 3 exists, then 2 will also exist. So because of this, it doesn't make sense to search in the right half at all. You can simply skip the right half and only search in the left half. So standing at a point, you can deterministically say whether to skip the complete left half or the complete right half. Hence binary search is applicable, and instead of trying out all the n possible choices here, you can only search for log n choices and be done with it. So you are searching in log n, or you are iterating over log n number of these choices, and for each choices what you are doing, you are iterating over all the substring of that size, so that is order n, right? And after that you are iterating over all such substring hash again and figuring out whether whether they are equal to one of the given character, so that is order n into c. So overall complexity is order nc log n, right? So even this is lot better than n square c log n, which was the previous n square c, which was the previous complexity, but still this is on the very edge of the given time constraint. So this may or may not pass given on how you implement it. So you have to somehow reduce this as well. So the key to reduce this lies in the fact that you are checking this hash with all possible hashes, all possible 26 hashes you have. But do you need to do that? The answer is no. Let's say along with this hash you are also storing the first character. So along with this hash you also know that the first character is, let's say, x. So if the first character is x, you can simply check with the hash of the x of length result itself, right? So if let's say you're checking for length 3, you will simply check that whether what is the hash of xxx, and if it is matching with this particular string hash, then only I will move forward. I don't need to check this with y, because I already know the first character is x, so all others should better be x, otherwise I don't care, right? So This way you can reduce this C as well from the given time constraint, and the complexity will be order n log n, which will surely pass the given time constraint, right? So if we have watched this point, I would strongly encourage you to pause and try to code this entire thing by yourself. The time constraint in the problem is bit tight, so you have to be conscious about the fact that you are not making this 2 or 3 n log n or stuff like that. So just try to avoid as many or as many non-required computations as you can. So next we'll be looking at the code before jumping to the next possible solution to this problem. So the code is straightforward as we discussed. This part is something we need to figure out the hash, or rather this entire part is something we need to figure out the hash of a particular string. So this I assume that you know, because I've discussed this in the past video. You can refer to that. I will link that in the description. This part is the new, where we are actually doing binary search from 1 to n minus 2, and inside the binary search, as we discussed, we are checking for m plus 1. So if m plus 1 is true, that is if there is a substring of size m plus 1, I don't need to check for substring of size m, m minus 1, and so on and so forth. I can simply skip the left half and check in the right half. So that's what we are doing. We are skipping the left half completely, and we are only searching in the right half, that is m plus 1 to r. So I've just made L as m plus 1 and r is r. Otherwise, I know that I can skip the right half completely and only search in the left half. So for that, I just made r to m, and right half will be completely skipped. Now what does this exist have? This exist is basically this entire piece. So what we are doing, we are first figuring out the hash of every character of the particular length. So we are checking whether a substring of size sz exists or not. So we are figuring out the hash of a sz number of times, b sz number of times, c sz number of times, and so on and so forth. So we are first figuring out the hash of all of them, right? And once we have the hash of all of them, we will simply check which of these like one of these hash should be the final hash of the string. So for that, what we are doing, we iterate over all the substring. So this loop is exactly equals to this particular loop. We iterate over all the substring, we figure out the hash of the substring, and if hash is not equals to the expected hash of ch, so notice this is the first character of the current string. So as discussed, to remove this c, what we have done, we simply check this whether this hash is equals to the hash corresponding to the first character of this string or not. So we just check whether it's matching with the first character's hash. If it is not, then I don't care about the substring, I will simply ignore it. If it is matching, I will just increment the count. And notice this is, I have put a vector here instead of a map, just to speed things a bit up, but you can use map here as well, that will also pass. So if the hash count is equals to 3, I will return true. And if this entire thing entire loop completes without being the hash count of any string greater than 2, I will return false, right? So hope this entire thing makes sense. If you have any doubts in this part of the video, feel free to post them in the comment section below. I would be happy to answer. Next, we're looking at the second possible solution. So second solution is based on the fact that the given string has a nice property. The property is it is made up of a single character, right? So we can utilize this property to simplify some of the things. So if there is a string, let's say a, and so you know that you can form two substring of exactly same size and exactly same characters from these this substring, and similarly you can form three substring of length 3 which are exactly same. Similarly you can form four substring of length 2 which are exactly same, right? So in a way, if you can just know what is the size of continuous A's or continuous B's or continuous any characters, you kind of already know what all substrings you can make and how many of them you can make, right? So let's just take an example and do a dry run to make things bit more clear. So you have this particular string, so you count how many A's you have or how many characters you have in continuous. So you have just one A, so this one A is able to make one substring of size 1. So you will say I have found one substring of size 1 which has all A's, right? Similarly the next thing is you have some B's, so you have total 4 B's. So notice, because you have 4 B's, you found one substring of size 4 which is made up of B. You also find two substring of size 3 which is made up of B. You find three substring of size B which is made up of size 2 which is made up of B's, and finally you've also found four substrings of size B of size 1 which is made up of B. So because they are all equal, you are able to do this, right? So what you can do, this is of length 4, and so maximum substring length is also 4. So you will, this filling up this array simply means that you are iterating over these elements one more time. So basically this 4 translates to 1 2 3 4 in the reverse order for B, right? Now comes A, so you have 3 A's here. This translates to you found one substring of size 3 which has all the A's, you found two substring of size 2 which have all the A's, and you found three substring of size 1, and you already have one previously, so you have in total 4 substring of size 1 which is made up of A's. And finally this B, so same thing, you found one substring of size 2, so previously you had 3, now you have 4 substring of size 2, and finally you have 6 substring of size 1 which is made up of B. Now once you have made this array, you can simply iterate over this array from the backward direction and see which one has greater than 3 count. So you will see that this has 0, this has 1, this is 1, this is 2, this is 2, and this is 4. So this is basically there is a substring of size 2 which occurred more than thrice, and because you are only considering the special ones, so there is no need to tackle the special ones. These are all specials by definition. So the answer here would be 2, right? So what is the overall time complexity of this entire algorithm? The overall complexity is what you are doing, you are simply iterating over the array and figuring out the how many character exist in continuous. So B occurs 4 times continuously, so you simply go and fill up 4 3 2 1 of B. So how many times B occur, you fill exactly those many, or you modify exactly those many number of cells here. So if B occur X times, you will modify X cells. Similarly this occurs x2 number of times, you will modify x2 number of cells. X3 number of times, you modify x3 number of cells. So in total you are modifying n cells at the end. So filling up this matrix is just order n operation. Now once you have filled this matrix, you have to iterate over these matrix from the back. So you will first go at 10, see the values of every character and see which of them is greater than 3. If there is none, you will try out 9. If there is none, you will try out 8, and so on and so forth. So iterating over this matrix require order n into c time. So overall complexity is still order n into c. Now notice that this order n into c in this particular scenario is slightly worse than n into log n, because log n in this case is less than 20. If you figure out 2 power 20 is roughly 10 power 6, but n in this case is 5 into 10 power 5. So you can assume that log n value here is kind of 20, and c in this case is number of characters. So number of character in this case in this particular problem is 26. So this solution is still better than order n to c, but if it is given that the s contain only first 10 in English lowercase characters or first 15, then this could have been a better solution. But anyways, this solution will also pass, and the best thing about the solution is this solution is very easy to implement. You can easily implement this entire thing in less than 20 lines of code. So I will not show you the code for this. This is really straightforward. I will paste one of the sample solution for you to refer in the description if you are interested. With that, if you have any doubts in any of the two approaches, feel free to post them in the comment section. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.